Grace. I got your email, but I didn't check my email after I sent you my email.
Yes, I know, but I already nothing happened.
Good, because I believe in you. I knew you would. I read your email and said, no, you can do this. I won't help you.
Don't reply.
I won't. It's better for me not to. It's better for you as well. Okay, do you have Excel open?
No, it open my.
Remember last week I said, would you like me to do the residual calculation again? Remember? The thing you forgot? Exactly, what's this? This is why I'm doing it again. Okay.
No.
Jeepers. You can get the special wipes from the supermarket. What? You got a virus? Your Steam's not working?
No. Well, that's how it's going for me. Like old people nowadays.
Not like my laptop still works. This is like old, powerful, ancient warrior. What? No Skype. No. Dropbox.
No.
Bluetooth.
There?
Oh yeah, Skype, yeah. I only have one person on Skype.
Me too.
Okay, can I start now? Yes? Make notes. Hareen and Andy, can I start? Yeah. You have Excel open? Yeah. Okay, so first I'll just make up some data. We'll say X and we'll say Y. Well, no, let me make it a little bit different. Okay. Can you see this okay? Well, we'll start anyways. So just to explain what we're doing. Can I show you? So you know, if I just draw this here really quick. Oh yeah, watch this now. I figured out how to do this. Nice straight line. Oop. Oh. Oh no. There we go. Yeah. Beautiful. Okay, so this is your X and this is your Y, and this will make Y equals MX plus C, as you know. And which part do we usually care about? We usually care about which letter, M or C? We usually care about the M. So often we have something we care about, let's call it, I don't know, K. It's a constant. And it's usually equal to 1 over the slope. Very good, yeah. So this is the thing that we want. But also you know that your K has a plus or minus uncertainty. So what we want to learn today, we want to learn how to calculate this uncertainty. This is what we're doing. I will. But first, you understand what we're doing here. The uncertainty, yeah, for the K. For this constant K.
K is R, and 1 over slope is R.
Yeah, or, yeah. For electricity, yeah. Yeah. I will. Now, can I go back to Excel? Oh my goodness, this is going to take a long time.
The K is we want.
Yeah, tell you what we want. So we know how to calculate the M. You know, we can draw a triangle, yeah?
Yeah.
But we don't know how to calculate this. Yeah. Okay. Now can I go back to Excel, Harry? Right. Okay, so the first thing to calculate is the slope. The M. And in Excel there's a nice way to do this. We type equals, you watching? Slope, bracket, then we pick the Y, comma, then we pick the X. So I'd have something like this. Yep. Yes, can I continue? Yes, continue. So next we'll get the C, and that is with intercept. And we highlight the Y's, comma, highlight the X's, close, enter. There it is there.
Highlight the Y first, right?
Yeah. Yeah. No. Okay, continue. Yes? So if we go back to our notes, we have now calculated the M and the C. Does anybody remember the next step in the calculation? No, that is okay. We have to calculate the predicted value. So for example, for this value of x, the hat, yeah. For this value of x, we should have this value of y. For this value of x, we should have this value of y. For this value of x, we should have this value of y. And as you said, Grace, these are called the y hats, the predicted values. Do you remember how to get the y hat? For example, if I call this one, let's say x1, how can I get this value here? Y hat 1. It will be m x1 plus c. That's all, because it's coming from the line. So let's use that now. Let's go back to our Excel. Now, we'll call this one y hat. So watch carefully, or go slowly. Equals m, but because m is constant, we put dollar signs on the a and on the 9. Times x, which is a2 here, plus c, which is here. And again, because the c is a constant, we put dollar signs on it. Okay. Alright, okay, watch. N, which is here, we put dollar signs on it, times x plus the c with dollar signs.
What is that line? Oh, okay, the B.
So this is what I got.
Oh wait, I see it that way.
Trying to stay calm. Did you get the same number?
Highlight all of A. Only one A.
1.
It's just only multiply 2 zeros.
Okay, one more time. Don't type, just watch, okay? Equals, now don't type, just watch, equals m, but then, because it's constant, we put dollar on the b and the 9, because it's a constant, times, star, x, which is a2, plus c, but c is constant, so it also gets dollars on the b and on the 10. If you haven't done what?
If you haven't put the constant,
The dollar? Yeah. Well, it might be wrong because the dollar tells Excel not to change this number, to keep it fixed. Yeah. Did you do that? Yeah? Now, now once you've done that, you can copy it down. Now, all of these are positive, so it's not a problem, but I was hoping one of them would be negative. Actually, I could have sworn. Oh, sorry. That's the y hat. Yeah, that's positive, so that's fine. Okay. So copy it down. Next we need to calculate is called the residual. So that's the difference between what we expect and what we observe. This is called the residual. This is called the residual. This is called the residual. This is the residual. This is the residual. We'll call it EY. So EY. Do you know how to calculate? Question?
I think it's residual.
Residual, yeah. How can we calculate the residual?
Equal residual.
One sec, huh? Right. It's like you're not listening. It's the difference between the data point and the line. This is the residual. Okay, so how could we calculate that?
Equal ABS.
Yeah.
Y minus Y.
Yeah, that's it. It's the difference between these two numbers. And the ABS is to make it positive. ABS means absolute. You've done that with John, haven't you? Are you sure? Anyways, I'll write it over here for you. Residual is the difference between the Y and the Y hat. So I get residual there. Okay, so we have this and we copy it down. It's the difference between Y and Y hat. Yeah.
So the change show where did you put a constant in X is formula.
Which formula?
X.
Oh, we'll do X hat now. Yeah. So, can we continue?
Yeah.
So the next one is the X hat. So, hey, I think you're in the wrong room. I sure hope so, because we have a double class here. Don't we have a double?
Do I see you in an hour?
Yeah.
In an hour?
Oh, you're 1 hour early.
Yeah.
Oh, okay. Do you want to sit down for some physics? Or?
No, you're all right.
You're okay, great.
Maybe at lunchtime we could run over with them.
Ah, yeah, we'll cover this at lunchtime then, no problem. So, alright, see you later. Okay, so, as I was saying, the X and X hat. So here is, for example, I need to draw this again. So let me see. For example, here is the Y, and this is what the X hat is. And for example, let's say this is another Y. Yeah. This is what the X hat is. So you can see that in this case we're looking at the we're looking at the horizontal residual. It's really the same thing, because here you can have Y equals mx plus c, but you could change that into x equals y minus c over m. So we can use this formula to get the x hat will be y minus x over m. So this is what we need to use. Okay? So you might want to write that one down.
Below the side is x equals y minus x over n, right?
Y minus x over n, yeah.
How much is c?
Oh my goodness! You're right, sorry, that's stupid. sorry, that's a C, isn't it? Yeah, sorry, that's a C, that's a C, that's a C, that's a C. Yeah, well, that's an ugly C. Okay, back to Excel. So here are x hat. You can see it's y minus c over m. So that's equal to... Okay. Is it possible that I could do this once, not 4 times? Yeah? So just watch very... Grace!
Yes.
Watch very carefully, please.
Yes.
Right, so watch. Equals, bracket, y minus c, bracket, divided by m. But the m and c are constants, so dollar on the B, dollar on the 10, dollar on the B, dollar on the 9.
If you write on the micro, then we should put a constant thing on.
Say again?
Show constant,
It needs the dollar to show it's constant, yeah. What? What? Great. I'm the best. Good teacher, good at football. No, I can't. Okay. My answer is a minus, so we copy this down. And also, again, we do the E residual for x. Guess what the formula is? Equals ABS x minus x hat. Close. Yeah, you know, it's the difference between x and x hat. Okay, continue? Yeah? Great. Let me just write down how many points we have. N equals 6. Right, so let me go back to here. So this is the formula we're using. The uncertainty in the gradient, in the slope, is equal to the average y residual divided by the average x residual divided by, now I always forget, is it square root or is it n? I can't remember. What did I say, square root or n here? No square root? Yeah, like this. Okay? Now, it's true that this is small, and it's true that this is small, but what you really care about is their relationship. It doesn't matter that they're small, it's how they're related. So for example, if the residual for the y was much bigger than the average residual for the x, would this be big or small? This would be big, because the top would be bigger than the bottom. So you don't care, it's good that they're small, but what's more important is their relationship. We're calculating this. Okay, so next, the average of EY and then the average of EX. Mean is average. You know this word from maths? Oh, sorry, maybe you don't. Okay, I'll just call it ABG for the moment. Average. You know average, don't you? So, is equal average of EY, close, equals average of EX, close. So there the y and the x is there. So my formula, I should also calculate square root of n. So that will be square root of 6. So now I can calculate my delta n. That's equal to bracket average y residual divided by average x residual divided by square root n. So we get this. Yes, here. You don't, why am I writing this? You don't need the square root n.
We should only put the constant in y hat and x hat.
One sec, sorry. What are you asking me?
Well, we should put the constant in only y hat and x hat, not
Yeah. Okay, so is this okay for, oops. Oh, I'll go to that in a second, but are these two okay? Alright, so it was average y divided by average x in brackets divided by square root n.
Average of the
Residual. There.
Yeah, because when I type it.
Did you type this in?
No. Oh, yes.
Yeah?
is the D level?
Of what?
D level.
That's the n, 6. Did you get this?
Oh.
It does. Okay, continue. Ah. Now, please note, this delta n is not the exact answer, but for this level, it's very good, okay? So at university, you will calculate it a little differently, not much, but I'm trying to do it the easiest way, okay? Now, not quite finished yet, because we don't want delta m. What do we want? Delta k. Or delta r, yeah. So if you remember, for example, if you had z equals, for example, x multiply y, and you know delta x and you know delta y, do you remember how to get delta z? It was from this formula, delta z over average z is equal to square root delta x over average x squared plus delta y over average y squared. Do you remember this? No, okay, that's great. And if you had powers here, no, you should remember this because Lorraine does this formula with you as well. I don't know what it's called. And the only difference is if you have powers here, m and n, then you put the powers in the front here. You do remember doing this with Lorraine and with Stephen, your physics teacher, don't you? You've done it twice now. This is the third time. Yeah. So, what's wrong? Okay. So, can I continue? So, for example, if k equals 1 over m, then k equals m minus 1. So, delta k over average k will equal square root minus 1 delta m over average m squared. So that means delta k over average k will equal absolute, or just make sure it should be a positive here, delta m, well, I know for the lab report it is, delta m over average m. So therefore, delta k equals average k over average m times delta m. we know this. Well, I suppose I don't have to write average here. We know this, and we can know this. Yeah. Yeah. But let's not forget what our k is. Our k is equal to 1 over m. You know, so we think that the average for k should be the same as the average for 1 over n. If you want, you can change this into, let me see, average 1 over m squared times delta m. That's what the delta k is, we think, about. Well, let me be a little bit clearer here. M is the slope. M with the bar is our estimate for the slope. So it's not like an average, because we only have one value for m. So it's like an average of 1, I suppose. It's not really an average. So if we want, we can say m and m hat are the same thing. M bar. F for slope. Okay, can I go back? Yep. Now, in fact, for your lab report with Ohm's law, I remember that the slope is nearly 1. So actually, it doesn't, for the electricity one, it doesn't actually matter so much about that, because the m is nearly 1. I think for Newton, though, that the m is like 1.5 kilograms. So it's more important. Okay. Anyways, delta k will be delta m over m squared. Let's go back here. So our k is equal to 1 over m. So our k is about 2. And our delta k, if we go back to the formula, is 1 over m squared times delta m. So, or in other words, delta m divided by m squared. This is recording also. Delta m divided by m squared.
You must put a square in our own.
How do you have k?
You don't, you should, but again, because it's a 1, in fact, I told students last year that they can leave it out because it's 1, nearly. Oh, okay. This year, it's funny because each year I do it a little bit different for how I feel. It doesn't really matter because the way I'm doing it is not the real way you would do it at university anyway. So I feel comfortable making some small approximations. So for example, here, Andy, I could say this is the same thing as about delta m because this is about 1. But K is 1 over m, yeah. That's the formula.
Is it normal in the university to do this all the time?
No, there is a quicker way to do it, but then you don't understand what you're doing. Like you can do it automatically, built in, automatic functions. For example, we use a function called slope to calculate the slope. How do you calculate the slope? By drawing the triangle. What I'm trying to say is at university, you won't do this whole process. You'll use an automatic function, a built-in function. A really quick way, yeah. Not like this. Yeah, well, what I'm going to do is, I'm going to use your numbers as an example, and we can see if we get a good answer. Now, tell me this. The K is 2, and the delta K is 0.84. So the delta K is pretty big, isn't it? Compared to K. Why do you think it's so big? Well, the reason is, anybody have an idea?
Delta K is the difference in...
Delta K is the uncertainty for K. Why do you think it's so big? What part of the formula is making it so big? Not the K. The N. The N is so small, there's only 6 points. Because if we make the N bigger, like 10 points, this will become smaller. Watch. If I make this, let's say 12, the only thing that should change is the delta K, really. You see how it decreased for 12 points. Yeah? So what I'm going to do, we'll use Andy's data as an example here to see if we get a good answer. Oh, well actually before I finish it, I should put in the lower and the upper. So the lower will be K minus delta K, and the upper will be K plus delta K. So this is the lower and this is the upper.
How did you get K to delta K?
1 over m. Here. Whoops, sorry. We can say K is somewhere between K minus delta K or K plus delta K. This is the lower and this is the upper. So for example, K is somewhere between, like 1.5 and 2 or whatever. How do you think? K plus delta K. How many data points do you have, Andy? 11?
Except X, Y, you can English word.
Yeah. 10, okay. So let's use that as an example. Yes. What do you need? Bathroom? That's fine. I'm just going to use Andy's as an example. Okay. Right, Andy, give me all the... Oh, hang on. Let me copy this down. Okay, give me all the X's first. The x will be the v. Yeah.
0.0495.
Okay.
And 0.0515.
Yep.
And 0.0535. And 0.057.
Yep.
And 0.0615.
Yep.
And 0.0675.
Yeah.
And 0.0715. 0.0845. And 0.0825.
Okay.
0.0855.
Right, so there are all the x's, and then the y's.
0.0465. 0.05455. And 0.0435. 0.0455.
455, yeah.
And 0.0545. And 0.0535. And 0.0575. 0.0645.
Yeah.
0.0645. 0.0665.
So here, the K is actually resistance. You got about 1.5? And the delta OR is 0.48. Yeah. So this is perfect. So we're saying that the resistor, its value will be somewhere between 1 and 2 ohms. And our best estimate is we think it's 1.5 ohms. So between 1 and 2 is our estimate for the resistance.
So this is for electricity.
In this example with Andy's numbers, it was for the electricity one, yeah. Now, I think your answer is a little bit too big, because I was expecting the lower to be less than 1, like for example, 0.9 to 1.9. So I feel like your numbers are a little too big, but it's not important. It's not important.
Conclusion, like error because of teamwork.
Yeah, whatever. Yeah. Did anyone else estimate yet? No. The resistance. And in Newton's law, what would it be? It would be the mass, the total mass.
Did it then 1 to 2 is better than that?
Actually, yeah, I think so. I think the mass should be 1.5 kilograms, shouldn't it? I don't remember what was the total mass. The trolley was about 600 grams, and you used about a kilo in total, was it? I don't know, maybe it's more closer to 2 kilograms.
1.1 to 2?
Something like this, I don't remember. So for example here, this one here would be upper, yeah, and this would be ohms, 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 ohms. The V is voltage and the I is current. And this one here. Now, please make sure you have the units in your report. A lot of students forget that they need units. So, for example, what's the units for M? Yeah, what is that? Yeah, 1 over ohm. So it's ohms to the -1. And for the C, what's the C? No, the C is where it crosses the y-axis. What's on the y-axis? The I. So this would be amps. The N has no units. What about this one? Average residual Y. What's on the Y? Yeah, and on the x, v. And delta m, it'd be ohms minus 1 again. So this would be, y would be, in this case, I, and x in this case would be v. There we go. Well, you can leave it as x and y, I suppose. So, Sophie, how's that now? Remember? And this is what I want you to do for both the electricity and newtons. Yeah. Also, again, just to show you something before you finish. In the notes, I said that, for example, if A equals B, if A equals 1 over B, I said the average for A equals 1 over the average for B. So, for example, if I have, let's say, here's A and here's B, and here's 2, 3, 4, and this is 1 over 2, 1 over 3, 1 over 4. The average here, 4, 5, 6, 7, 8, the average here is 3. And the question is the average here 1 over 3? Because this is a 3. So we can calculate it. 1 over 2 plus 1 over 3 plus 1 over 4 over 3. So let's help the teacher out here and tell me what you get. You got a calculator? Yeah. So you see, it's not quite the same. It's actually 0.36. It's not 0.33. So back here, Andy. No, it's not the same, but my point is, for all of this calculation, it's approximation. So, for example, I told you that delta m equals residual for y over residual for x divided by square root of n. In fact, that's not 100% true, that's only 99% true. There are other parts in the formula that I deleted because they're too difficult for this level. And that's okay. Also, like I said here, 1 over A average equals B average. It's not exactly true, it's nearly true. What else might have been an approximation? This formula here that Lorraine uses and that I use, again, this is also approximation. Now you see, this is fine because the approximation is pretty good. For example, here, where's it gone? .33 and 0.36, it's not too bad. The approximation is good, but the reason we use it is because it makes it really, really much easier to do. So you have a small price to pay, but the reward is your calculations are a lot easier to do. And this is actually okay in physics at this level and a bit at university level. It's okay if you approximate as long as it's still pretty good, especially if it makes the work a lot easier to do. This is acceptable. Maybe it's not acceptable if you were doing a PhD, but it's acceptable for university and high school students. Okay. Right, is there any questions about this whole process? Now, I'll upload the video again later today. Do you think next Monday you could have most of the type report done? We can have a look at it in class next Monday? Yeah, 1 week. Not enough time? Oh, what day? What day is that? Monday? Ooh, okay. What day next week for physics then?
Friday.
Not physics on Friday.
Thursday.
Thursday next week? No, what I want to do is before you submit the physics, I want to check it in class, and I want you to work on it in class. So what day next week is good for you? Tuesday? Yeah. Thursday is okay? Yeah? My goodness, I hope you have the handwritten report done by now. Do you, Harry? This I can check on tomorrow's class. Tomorrow, I want to have a look at your handwritten report and I want to see it finished. Okay, Kareem? So I don't want to hear, oh yeah, I just have to do this thing later. No, I want to see the finished book tomorrow for the physics. And then, yeah, tomorrow. Oh, what, Amanda? You can finish it tonight, I suppose. And then Thursday next week, I'll have a look at the type report. Thursday next week, okay? And then we should be good, I hope. All right.